multiplication series, maths again, and a development really on short division. So I have covered short division and double digit short division in separate videos. Although with double digit short division, you don't usually get remainders. So what I wanted to do was just enhance the way we deal with remainders, show you what we usually do, and then try and push things on to year 6, year 7 and beyond. Show you how to do a remainder in a fraction and a remainder as a decimal as well, which can be difficult, but once you understand the method, as with anything, it's relatively straightforward. So I'm going to keep the same calculation 3 times through. I'll show you the normal remainder, the fraction remainder, then the decimal, show you a couple more arithmetic examples, and then something from an actual SATs paper so we can see how we apply it in a word problem. So let's have a look. So we have 57 divided by 4. So I'm asking myself in my head, how many times does 4 fit into 5? Once. And I've got a 1 spare over there. And then it's now, how many times does 4 fit into 17? If I'm not sure, I'm going to write my toolkit over on this side. Up to 16, up to 20, that's all I'm going to need. And I've got 4s into 17. It goes 1, 2, 3, 4 times. And then usually what we do is we go, oh, well, we've got 1 left over, so we just put remainder 1 because we wanted to get to 17. We could only get to 16. And the difference between the two is remainder 1. And we just put R1 at the top. And that is fine for most of primary school. We understand that there is a 1 left over. It doesn't divide exactly perfectly, but we can do better than that, and we kind of need to as well. So with a fraction remainder, you're probably thinking it's going to be really complicated, but it's actually really straightforward. So I'm going to do my toolkit down the side just to kind of drill those good practices, good habits. How many times does 4 fit into 5? Well, once, with 1 left over that we exchange over into the ones column. How many times does 4 fit into 17? It's still 1, 2, 3, 4 times. But actually, what we're going to do with that 1, so I would be writing 1, is I'm just going to put it on top here. So actually a remainder is a quarter. So where you were going to put that remainder, you just plop it over the top onto your divisor, and it is 1/4. That's just literally simple as that. So you've got 14 1/4. Here's your answer. How many times does it fit in? And yeah, all you got to do is just draw it on top of what your divisor is. It works every single time. But most of the time, you're not really asked for a fraction remainder. More often than not, you will need to write your remainder as a decimal, and this is how we're going to do that. So, same applies. Really quick toolkit. Probably don't need it at this stage after we've done the same question 3 times, but here we go. 4 fits into 5 1 time with 1 left over, and then we've got 1, 2, 3, 4. And now, instead of just saying, okay, we need to just write a 1, or we put the 1 on top of the divisor, we're going to create a place to exchange that 1 into. So I'm not going to change my number, but I am going to put a decimal here. And I'm going to change that 57. Not actually change the number, but I'm going to make it 57.0. Now you'll notice that 57.0 is exactly the same as 57. All I'm doing is I'm using the tenths column to create a place to exchange into. Because I've got a decimal at the bottom, I'm going to put a decimal at the top there so I don't forget and I don't get an answer that's way out of proportion. So now I'm going to put that 1 there. Now that is a 10. And how many times does 4 go into 10? It goes in twice. And then I still have a 2 left over. So I'm just going to create another column. You'll notice 57.00 is the same as 57. So I'm not altering what we're dividing, but the 2 that I've got left over, I'm putting there. And then how many times does 4 go into 20? Exactly 1, 2, 3, 4. 5 times. So your answer there, 14.25. And if you didn't believe me on the fraction remainders, if we go back, we look at 14.25, we see that our answer here was 14 1/4, and we know that a quarter is the same as 0.25. So there's the support that they mean the same things, we're just representing them in different ways. Here's a few more arithmetic examples so we can just run through and drill that decimal remainder method. How many times does 3 fit into 1? It doesn't. So we exchange that 1 over there. 3 fits into 18 6 times exactly. 3 fits into 7 twice, but we've still got 1 left over. So we could do remainder 1. We could do 1/3. But you're going to notice what's going to go on here. We're changing 187 to 187.0. Put the 1 there. And you'll probably notice if we've got 1/3 over here, this is going to be an interesting decimal point up there. It fits in 3 times into 10. 3 fits into 10 3 times, but there's always going to be one left over. So you're going to create this repeating pattern of create a place to exchange, make it a 10, then it's a 3. Create a place to exchange, make it a 10, then it's a 3. And if you know what 1/3 is as a decimal, it is 0.3333 recurring. So you can do that as many times as you feel comfortable, or put a little dot up there to show it's recurring. That 3 goes on forever. As an example, sometimes the pattern does just carry on and you need to know when to stop. Some of them, it will carry on a little while, but it will resolve itself in a few decimals. So have a look at this example down here. 113 divided by 8. 8 does not fit into 1. Exchange the 1 over to make it 11. How many times does 8 fit into 11? Once, with 3 left over. And if we're not so confident on our 8s, which lots of people aren't, that's fine. 8, 16, 24, 32, 40. Okay, how many times does 8 fit into 33? Once, twice, 3, 4 times there, with 1 left over. Before we do anything, we would just put a remainder 1 up there, but we're better than that now. Change 113, or put the 0.0 on. Put the decimal point at the top so we get our answer correct. And we exchange that 1 into the tens column. How many times does 8 fit into 10? 1 time. 2 left over. How many times does 8 fit into 20? 2 times. And now we have 4 left over because we've got to 16. So we've still got to exchange the 4 that we couldn't get rid of. And now how many times does 8 fit into 40? Well, we can see that in our toolkit, so that's reassuring. Once, twice, 3, 4, 5 times. Done. 14.125. Or 14 and 1/8 if you were going to make it a fraction. And 0.125 is the same as 1/8. But really you're going to need to use the decimals a lot more than you are the fractions, but just showing you the coherence between fractions and decimals there. Hopefully that's making a little bit of sense to you. Just create the place to exchange and carry on as if it's a normal division. Here's a relatively long question. So a farmer is packing eggs. Each box holds 6 eggs. He has 980 eggs to pack. How many boxes can the farmer fill? And that's in bold, so we need to be careful about that one. Using 980 eggs. So you've got 980 eggs. 6 to fill a box. Let's have a look. So 6 goes into 9 1 time with 3. Might just need to do a toolkit down here. 6, 12, 18, 24, 30, 36, and onwards. And to get to 38, 1, 2, 3, 4, 5, 6 times, with 2 left over. And then here, 3 times. You could do a decimal, could carry on. And we've got 6 goes into 20 3 times with 2 left over. Not changing the number, still 980.0. And 6 goes in there 3 times with 2 left over. It's going to be thirds. So we're going to have this continuing pattern of on and on and on and on. But the question asked is how many boxes can the farmer fill? Well, we've got a third, 163 and a third. So we're not interested in this end bit. That's not going to fill a box. So just ignore that. That's why we need to have a bit of number sense. What's the question asking us? It's written in bold font, so please don't ignore it. And it even says full boxes there as well. So 163 full boxes. Give yourself a mark. Well done, me. How many eggs will be left over? So we've got 163.333333. So we could do just a normal remainder here. It's actually asking you for a normal remainder. We can't say and a third of a box. Well, you could have the number sense to understand that a third of a box will be 2, but it's looking for you to calculate a normal remainder here. So instead of, if I just erase this bit over here, once we get to the end of the calculation, we've got the 163 full boxes, and that's brilliant. How many times does 6 go into 20? Well, it fits in 3 times to get to 18. You have a remainder of 2. And that is what the question is asking us. It's to realise a remainder of 2, and we have 2 eggs left over. On mark, tick. We are now light enough on our feet and we know our method well enough that we can either say, or we can just draw it over there for a fraction, 2/6 of a box, and we'll notice 2/6 of the box is 2 eggs, or 0.33333, well, a third of a box is again 2 eggs. So you can see, as long as you understand the method, it doesn't matter how you get there, you can answer the question. But sometimes you'll need to just use a traditional remainder, as we have here. Rarely will you need a fraction remainder, but sometimes. And then having a decimal remainder is really the gold standard. It's the most useful one, really. Hopefully that makes sense. How I remember it is just create a place to exchange into. You're not changing that number. So go back up here to 57. I'm creating 57.0. I'm not changing the number. I'm just giving us a place to exchange the number into. And please write your decimal points in early, because otherwise you're going to forget to put it on your answer line and your answer is going to be all out of sorts. Even though you've done your division beautifully, it's just not going to make sense because it's not going to be 10 times bigger than it should be or 1,000 times bigger than it should be. So again, we just stick to the method that we know, and hopefully with a bit of number sense, you're going to be able to approach arithmetic questions or word problems, written questions, with the same skill and confidence. Hopefully that helps. Let me know what other maths topics you want me to cover. I know there's still 1,000 to go, but this is one we get stuck on quite a lot in my class. So I thought I'll put up some short division with remainders and demonstrate how to do decimal remainders primarily. Make sure you like and subscribe, and give me a comment if you can as well. And I'll see you again for another video. Ciao.